Okay, here's the review for the slope-intercept form, direct variation, and functions. So first off, we're going to look to see if this is the function. So we're going to, or look to see if it is a function. So we're going to look at our x values and see if they repeat. And since this one does not repeat, so for every input there's exactly one output, for every x there's exactly one y value, and that means that this is a function. Looking at number 2, again I'm going to look at my x's. Right here I see that I have 5 appearing twice, and I see that it's paired with a 2 and paired with a 3, and it cannot be paired with two different things, so this is not a function. Number 3, we're going to look to see if this passes the vertical line test, because when it's graphed it's easy to tell. Let me get this ruler here. And so I'm going to take my ruler and I'm going to look here, and so there's a vertical line right here, and I'm going to keep going across and make sure it passes the vertical line test, and it does, and so this is a function, yes. Now number 4, again I'm going to look at the vertical line, and what's nice about having the grids is it already has that vertical line, because these are the x values. So this is like the point 1, 2, 3, 4, 5, 6, so a -6, +2, and you could really list these points, 1, 2, 3, -3, 1, 2, 3, 4, 5, 6, +6, 1, 2, 3, 4, -4, and 1, 2, 3, 4, 5, 6, 7, -7, 1, 2, 3, so 3 and a -1, and then we have 3 and 1, 2, 3, 4, and you can see right there that I did the 3 twice, and that was paired with a 4 and paired with a -1, which they are on the same vertical line, so that means they are not a function. Okay, again, number 5, look to see if it passes the vertical line test, and it does, and so yes, it is a function. Right here I have this mapping, and so I have a -1 paired with 7, 0 is paired with 3, but it's also paired with 5, and because it's paired with two different outputs, that means it's not a function. Now remember, if you have an ordered pair, you can make this mapping too. Okay, the next page. Tell whether each relation represents a function. Right, yes, it is a function, or no, it is not a function. Explain why or why not. So I look here, and I can see that this one is not a function, so this is no. And why not? And we can say that it does not pass the vertical line test. Now number 8 here, is it a function? Again, it's a no. And this is a vertical line, and so why? And this is a vertical line. So if I were to look at this 1, 2, 3, 4, it would say x equals 4 all the time. And so that means that it pairs with all these different y values right here. And I could keep going on and on. All these different y values it pairs with. And so therefore it is not a function, because every input has to have, or every x value has to have exactly one y value, and they cannot be different values. So again, it has to pass the vertical line test, and it cannot pass the vertical line test if it is a vertical line. Okay, let's look at number 9. Got -3 with 10, -2 with 5, 0 with 2, 1 with 2, and 2 with 5. This is a function, and a lot of people would say the x don't repeat, and that is true, the x don't repeat, but we do want to say for every x value, there is exactly one y value. Okay, let's look at this one. Asks if it is a function and it's a mapping. And if I see here, I see that the 0 is paired with 1 and the 0 is paired with 5. And so is it a function? No. And why? Because the 0 is paired with 1 and 5. And it only can be paired with one value, not two different ones. Okay, number 3, we have a function and they give us the ordered pair for it. It can be represented in several other ways: create an equation, rule, or pictorial mapping, graphing, and tabular description of the function. So I'm going to look at my x values first. And they already tell me it's a function, but I'm going to go ahead and put my x values here. And that always goes on the left, and I put them from least to greatest, which they already are written in least to greatest. Then I look at my y values, which I'm going to put in the second mapping. Again, if I look at them, they're already in order from least to greatest, so I'm just going to list them. Now sometimes people will just leave it like this, but you actually have to pair it up by drawing an arrow. And so 0 is paired with 3, so we need to draw that arrow. 1 is paired with 5, 2 is paired with 7, 3 is paired with 9, 4 is paired with 11, and 5 is paired with 13. They don't necessarily always go all the way straight across like that. Obviously we had some over here that were crossed even though this was not a function, but functions can have them crossed like that as well. Alright, for tabular, I'm going to go ahead and write those same points down. And tabular just means it's in a table. So this is showing the different ways that I can represent functions. And so this next one here, I'm going to graph it. And so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15. I don't need to go any further. That's good enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's again good enough. If I were graphing something else, I actually were given the x and the y values, and this function of x, another thing is called, it's just y. Function of x is always y. And but if I had these as other labels between x and y, I would need to label my x and y axis with that. So now let's graph it. 0 and 3, 1 and 5, 2 and 7, 3 and 9, 4 and 11, and 5 and 13. So those are my points. And I wouldn't necessarily connect them. I would definitely connect them if I had an equation of a line, but since I started out with just points, I'm just going to leave them as points. Now it does say it wants a rule, so what I'm going to do for the rule is I'm going to write it in slope-intercept form. So that means I need to find the slope, and to find the slope it's change in y, so 3 to 5 is plus 2, over change in x, plus 1, so change in y over change in x is 2 over 1, which is 2, and so that's my slope, so y equals 2x plus my y-intercept, and my y-intercept is the value of y when x is 0, so right here it tells me that my y-intercept is 3, so my equation of y is y equals 2x plus 3. Now remember, if you're writing an equation for your function, and if you have an equation, it's always a function, unless it's x equals. But y equals is always a function. And so I would just double check to make sure that it works. So for example, this one was 5, I would just plug it in. 2 times 5 plus 3. Does it give me my 13, which is what it's supposed to be when I replace the x with 5, and then I would get 13 for y. Next page. Number 13 is the following map on a function. If it is a function, explain what you would need to do to change it to make it not a function. If it is not a function, explain what you would need to do to make it a function. So I'm going to look at my mapping here, and I see for every input there's exactly one output. So yes, this is a function. To make it not a function, I would need to pair -4, -1, 0, 2, or 7 with another number. Than what it is already paired with. So for example, if I took this 0 and I paired it with the 2, now it's being paired with a -5 and 2, and therefore that would make it not a function. All right, number 14, which of the following or set of ordered pairs represents y as a function of x? So again, we're going to look at our values and see if we repeat, and right here I see that I don't repeat. And so A looks like that's going to be the answer, but let's just double check. And if I double check on the B, I see -1 is paired with 0, and -1 is paired with a -8. On C, I see a -4 is paired with a -2, and a -4 is paired with 1. And then for D, I see that 2 is paired with 3, and 2 is paired with 4. And so right there, I proved that A was the correct answer by making sure that all the other ones were not a function. That helps me make sure that I graphed it correctly. Or not graphed it, but I checked it correctly, and I read the question correctly, is what I should say. Okay, the next problem. Okay, the number of students in athletics at Reagan A is related to the number of students not in athletics N as shown in the table. So we want to graph it, and it has some done but not others. But if I look here and I take 80 divided by 2, I see that's 40. And if I take 400 and divide it by 10, that is also 40, which tells me that this is a direct variation, because remember, if you take y and divide it by x and you get the same number, it's a direct variation. So 1 times 40 would be 40, 2 times 40 is 80, 10 times 40 is 400. So if I take 240 divided by 40, we would get 6, which is 240, so that tells me that that's what that is there to fill in my table. And I'm going to go ahead and graph it. So let's see, 1, 2, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can count by ones here and still graph all of my data. 2, 3, 4, 6, 7, 8, 9, 10. So this I will need to go up to 400. So this one here, I'm going to count by I could count by 40s, and that would make it kind of easy. So let's go ahead and do that. So 4, so it's basically 4, 8, 120, 160, 200, 240, 280, 320, 360, and then 400. And so I can graph 1 is 40, 2 is 80, 6 is 240, and 10 is 400. Now if I look at this here and I were to graph this, now I wouldn't necessarily have to connect this, and I probably wouldn't connect it in this situation, because if I connected it, it would mean that I would have 1.5 or a fraction of something here, and since we're talking about students, we wouldn't do a fraction. But I would look to see if this is a straight line, and I can see that it is a straight line, so that that would form a straight line. And so that tells me it is a direct variation. It's going to go through the origin, and that makes sense in this situation if I'm referring to students in athletics and students that are not, and in comparison, and that would be 0, 0. And so I'm not looking at A students, basically. So does N vary directly with A? Yes. And why or why not? For every one student in athletics, there are 40 students not in athletics. Write an equation that represents this, and that would be N equals 40, which is my K in a direct variation. So Y divided by X equals K, and K is your constant of proportionality. So N equals 40 times A, because 40 times A, in this case 1 would be 40, in this case A is 2, so 40 times 2 is 80, and that's what N is. And so that's how that works out there. Okay, on the next page, for 18, what does the constant of variation change mean in this problem? And it's 40 non-athletes, or also call them non-athletes. So 40 students not in athletics for every one student in athletics. Number 19 says finish filling in the table, and I already did that. Okay, number 20. Chantel won 9 out of 15 tennis games that she played. So she won 9 out of 15 played. At this rate, which of the following is the best prediction of the number of tennis games she will win out of her next 12 games? So that is a proportion. So basically when I look at this, I can say this is 9 out of 15, which if I simplify, this is 3 out of 5. And this isn't very good proportion, I just realized, because this isn't an even number. Because we would, to solve this proportion, I would go for 3 every 5. So basically what I would say here, since this is 12, it's definitely going to be less than 9, because she wins 9 out of 15. We should have done a number that was simplified down. But if I can't figure it out exactly, I would estimate, and I could also just do the cross product. So 9 times 12, which is 108, and then divide it by 15, and to see how many that would be. And let's see, calculator. So let's see, 7 would be 105. The remainder of 3, so that would be 7 and 3/15 or 7 and 1/5. So I would say about 7 7. What is the best prediction of the number of games she will win? And I would say about 7, yeah. Just leave it like that. Verse 21, which set of ordered pairs represents y as a function of x? Again, look at the x's here. Why do I think this is one we just did? Because it is. So this is a repeat question. This was the same as number 14. Okay, make sure you do study your notes on functions, but that's primarily what the test is on. Now remember that don't forget how to do slope, and you can always go back to where I talked about finding the equation of a line, which is right here. So remember here how to figure out your slope and your y-intercept, because you always need to know how to do that.